Hey guys, and welcome to Functional Print Friday. So I was blown away by the number of you that reached out to me after last week's video where I talked about Octoprint and Orca Slicer modernizing the workflow on this printer. And what I'm blown away about is so many of you reached out to me both directly and down in the comments and asked me about the other mods on this printer and if I would go over them. So here we go. So I already talked about this single piece of aluminum that basically laminates the whole front of the printer and solved the problem of the whole thing racking back and forth. If you missed last week's video, go check out that video. I talk about it a fair amount there. But I do also have a scan of the original paper template that I made for this, and I will make sure that that is in the STL pack for download for this week's video. So if you do want to print that out, transfer your own onto a sheet of aluminum and cut this out on a bandsaw or with a jigsaw, you can absolutely do that. But let's dive into the other mods on this printer. Okay, one thing I want to mention right away is not all of the parts on this printer are of my own design. Some of them are mods that other people have designed that I have added to this machine, and I will try and differentiate between those where I remember which was which. Remember, it's a while ago. I did most of the mods on this printer in late 2016, early 2017. The upgraded x-axis on this machine is the smooth x-axis for Prusa i3. And I had to make some adaptations to get it to work on this machine, but I was able to find the original Thingiverse link for the smooth x-axis that I downloaded, and I will make sure that that is linked down in the description of this video. But if I recall, the key pieces that I needed to make to get it to work on the ANET A8 were a longer tensioner rod here. This actually goes all the way back and is pulled in by this knob back here. I think the one in the kit was just too short for this machine without replacing the belt, and I just didn't want to buy a new belt. This was definitely worth doing because it makes adjusting, there's actually two ways to adjust this. You have sort of a rough adjustment with these bolts here that pulls this whole thing further away, and then you have a fine adjust with this knob here. So it gives you a good amount of adjustability to keep this belt nice and tight. And I did actually eventually end up replacing this belt with an upgraded one, I think from Gates anyway, that had I think like fibers in it so that it didn't stretch as much. And now honestly I never really adjust the belt. I think the last time I adjusted the belt on this machine is probably 2-3 years ago, and it's holding tension really nicely. The other part here for the x-axis that I had to create was for the end stop on the x-axis, and the one that comes with the Smooth i3 kit is actually a small block that keys into like a little L-shaped cutout on the bottom of this part, and it kind of looks like this one, except mine is actually not just this part. Not only is it larger to accommodate the end stop switch in the ANET A8 kit, it's actually one piece. It's that same orange piece that you see running all the way up here and coming up to here, because the wire for the end stop is actually in a slot inside that 3D printed piece. It'll make more sense when we look at the STLs, but it not only does it provide a mount for the end stop, but it provides physical routing for that wire, so that wire isn't just dangling around back here getting caught up in something. I believe the fine adjust on the Z-axis, which is what this is the end stop for the Z height, and you adjust it just by inserting a small driver up here and turning this guy up or down, which just raises or lowers the space, so it changes the end stop point. I think that was part of the Smooth i3 kit. If not, I will try and find my STLs for both the mount down here and for this piece. Maybe it's this piece that's part of the Smooth i3 kit and I designed this piece down here. I'm not 100% certain, but any of the STLs that I can dig up for this machine, I will make sure are included in the STL pack. The air guide here on the fan is not my design. This was an off-the-shelf design from Thingiverse back in the day. I will try and find the original page that I got this from. If I can't, I will share the STL. And by chance, if there's any STLs that I end up sharing as part of this video that are your design and I just couldn't find the original source, please just let me down in the comments or reach out to me on the contact page on my site. I am 100% happy to credit you. It's just, it's been so long ago since I printed and installed these parts. I actually don't remember where I got all of them. The Y-axis tensioner is definitely my design. I remember making this, and I do still have the STLs for this. There's several other variants out there that are similar to this one. Mine, the part itself is actually curved, and it's curved to get the height of the pulley up here to run true back and forth. The original kit for the ANET A8 had this pulley running at a weird angle, like it was on a downward slope. So the bed actually did not move consistently with the same number of E-steps on the stepper motor. This raises it up to the correct height and gives you the ability to tension it by turning this knob up here. The design of the brace up here on the front of the y-axis is my design, and it also includes holes over here to access taking this bolt out here if you need to swap out this bearing up here. I think I ended up replacing this bearing once because it wore out, and then thought, well, geez, if I'm going to be replacing this bearing all the time, I'll make sure I build in the ability to get it in and out easily, and then it never failed again. So I think maybe the bearing that came in the kit was just super cheapo. Now, worth noting, this brace in the front relies on being screwed down to something, and that brings me to the base on this machine. I originally had this machine actually bolted right down to the bench top where it sat, and it ran that way for probably 5 to 6 years, and it worked out really well, but you know, there's a kind of a portability issue there, right? Because it's literally bolted down to the bench. When I got the Prusa Mark III and moved this machine, I came up with the idea of just cutting this base out of MDF, and I spray painted it silver. And you do want to go with a fairly thick MDF if you copy this, and I don't have any drawings for this. I think I set the printer down on a piece of MDF and then went around with a pencil and drew a rough outline, and then just came back and made sure that all of the curves and lines were true to the actual frame of the printer. But I mean, you know, you don't have to make it as nice as this one. I think I ran it over the routing table to round over all these edges before I painted it. You could literally just stick the machine on a hunk of plywood and screw it down, and it'd be fine. Or if you're not going to move it around, just bolt it to the bench like I originally did. Okay, at the back of the y-axis here, on the back frame of the machine, the gray part is PLA plastic. The black part here with the 2 screws, that is actually a hunk of wood that holds the tension really strong up against that stepper motor. I went through a couple different iterations on this design back in the day, and I kept having issues where it was flexing just a little bit and putting the axis of the shaft on the stepper motor out of square from the direction that the belt was running. There's other designs out there that might be better than mine that wouldn't cause you to actually have to go cut a block of wood to put in place there for this brace. So check out other stuff that's available. I mean, this one works really well, but you'd have to not only print the part, but also cut up a block of wood to fit in there if you want to copy what I did. The rear frame of this machine is just notoriously weak. The whole thing would sort of bend into a C shape without a brace back here, because the frame thins out, and then you have tension being put on here by these threaded rods that run the length of it. So you really do need to do something to brace the back of the machine if you haven't already. Probably the very first mod that I made to the machine, and actually one of the first ever functional prints that I designed, was a dual MOSFET mount. So these are off-the-shelf MOSFETs. There's 2 of them here, one for the heat bed, one for the extruder. And the orange part that you see them sitting on, that's marked hot end and I think bed. Again, that was one of the first functional designs that I ever made, and it ended up being a really popular design on Thingiverse. I'll find the original link to that, and rather than just provide the STL for this, because you can just grab it right from Thingiverse. And while we're talking about, so if you don't know, this was the reason these printers had such a bad name, because they didn't come with MOSFETs. There's really small, like underrated MOSFETs on the main board for this, and these things caught fire quite a bit because the amount of current that the bed on these was pulling was well beyond what could really be handled by both the terminals and the MOSFETs on the board. So a hugely popular upgrade on this machine, and really it's not an upgrade, it's more of a safety upgrade, is installing MOSFETs on here. At least one for the bed. I think most people tended to go with one for the bed and one for the extruder, just because of how poorly designed the power switching was on the main board for the heat on here. While we're on the electrical topic, another change that I made to this machine was swapping out the stock wiring for a really soft silicone wiring of a thicker wire gauge. It's hard to see because it's covered up with this plastic wire wrap, but these wires here are like a silicone shielding on them. They're extremely flexible, like extremely flexible. So they don't hold their shape over time, and all of that back and forth motion with this axis, because they're attached to the back of the heat bed. The insulation on the original wires was starting to crack after probably only a couple hundred hours of use. I replaced it with these, and then I also put couplers on here as well. This is for the thermistor. This is a JST style connector, and this is a Dean's style connector for the rest of the heat bed. I'll link to these parts. The Dean's connectors were largely replaced by, I think, XT60 connectors in the hobby space. This is where the Dean's connector came from, was the RC hobby space. You could use a Dean's connector, which there's plenty of copies on from Amazon, or an XT60. I'll link to both down in the description of this video. If you missed last week's video, another mod that I did to this printer was adding a Raspberry Pi to run Octoprint, and if you're not running Octoprint, I would strongly recommend doing it. It was already a great thing to do, but now that you can interface directly from OrcaSlicer and Prusa Slicer to Octoprint to send print jobs directly to the printer, 100% worth it. A couple of the mods I want to talk about are up here on the extruder, and some of them we can see and some of them we cannot see. Inside here, the filament path through this extruder is not very good. It's wide open in places, and it's very much an acquired skill to change the filament on these printers. You've got to get the end of the filament pretty straight, a nice sharp cut on it, and feed almost straight down. This is one of those that is not my design, but this is a piece, I have a spare one here, that mounts down inside the extruder and provides a much better constrained filament path as it goes through the rollers, the feed rollers on the printer. If you haven't printed this part, or you don't remember installing something that looks like this is a big quality of life upgrade on the extruder. It makes it a lot easier to swap filament on this guy. And again, this one's not my design. I will link to the design of this one. And this is one I have a spare because I printed this in ABS on one of my Bamboo Lab printers. You could probably print this in PLA and it might be okay, but if you have enough heat creep over time, work its way up on a long print, this guy's probably going to melt down here in this part. This hollowed out section on the bottom goes over essentially the top of where the PTFE tube comes up through the threaded section on the hot end. So I would print this in ABS if you have the ability to do so. All right, the last thing to talk about on the extruder, and this is just another quality of life improvement, is the cap that covers the bolt here. And this is how it looks in kit form when you build this machine. You actually push down on the top of this M4 machine screw to release the tension on the extruder. I'll try and keep my thumb out of the way so you can see what's moving. This whole part here swings, and that releases the spring tension on the roller so you can get the filament fed down in there. The problem is the spring tension is actually quite high. You can see my thumb turning white there, just pushing down on this guy. And you've got to keep this held down for as long as it takes you to find a sweet spot to feed that filament in. So it's actually quite hard on your thumb, and this is not my design. This is someone else's design. It's meant to just fit right over the top here, but you know what? The truth is I actually hate this thing because it doesn't stay in place. I think it's meant to press down over that this nut down here on the bottom, but the darn thing never stays in place. It flips off. You know what? Let's make something better. Yeah, that was totally worth the 1 hour distraction to go make that. I mean, who doesn't love distractions? All right, and here's the design for all those parts that we just took a look at on the printer, at least all the ones that I could dig up. And actually, I realized there's one that we missed. There's the power supply cover, and I am pretty sure this is not my design, but I cannot find the original part for this. I can't find where I downloaded it from. I looked through all the power supply covers on Thingiverse, and it doesn't look like any of the ones that are up there. So it's possible this design has been pulled down for some reason. So I'm going to include the STL for this in my STL pack, but I'm certainly not trying to steal anybody's work. If you know who originally designed this, or if you're watching this and this is your design, please let me know. I can either pull it out of the STL pack and link to your design, or I can give you credit down in the description of this video. But I am going to include it here because I am really happy with the one that I have. I think this design also enables you to use the original screw for the power supply, if I recall, with this this deep bore here. So again, if you know where this design came from, let me know. I'm happy to correct that, but I do not believe it is my work. I do not remember designing that. So let's take a brief look at everything else here. This is the dual MOSFET mount. This is definitely my design. Not that it's that impressive, but it is one of the very first functional prints that I came up with. This is probably maybe the third thing ever that I designed. So I guess for that reason, I am rather proud of it. But this mounts using this hole and this hole onto existing holes on the frame of the machine. And the spacing here on these risers here is the exact spacing for those MOSFET boards. And if they're still sold, and I'm pretty sure they are, I will link to those as well down in the description of this video, the MOSFETs that fit perfectly on these pads. Next thing to look at is the brace for the front of the printer. And this again is designed to, I mean, it'll work without bolting it down to, your work surface or bolting it down to a board. It's still going to stiffen the front and cause those forces at least to get transferred down to this front foot here when that front tries to bend downward. But this works a lot better if you actually do mount it to a board or mount it down to your desk surface. And this has that hole on the side to access the tensioner for the Y-axis. And it's a good segue into this part. This is the tensioner for the Y-axis, and you can see the curve in it. And there's a cutout here to hold the nut for the bolt that goes through here as well. The pulley for the Y-axis in the front sits between these two pieces, and it does use the same pulley that the kit comes with. Although that piece is worth upgrading. The original one, like I said, didn't last very long for me. This is the pad that keys into the two holes in the front of the printer, and this piece up, that's actually the pad, is this piece here. This piece just keys into the printer, and this design really just carries up to support this piece here. This is the pad on the front of the printer that bolt tightens into so you don't damage the front of the printer, and to kind of give it a wider surface to tighten down onto. And I realized the actual thumb screw part, that I did not design. I stole that off somebody else's design. I do not have the STL for that. But it should not be hard to find a thumb screw sort of press-in design for, that would have either been an M3 or an M4 machine screw. Brace for the back of the machine, and this keys into everything on the back of the machine as well. There's a hole in the back of the frame that this keys into. This lines up with, I think, the fastener that goes through the back of the frame here. And this cutout is large enough to accommodate both the stepper motor and that wooden block back here, if I recall. I think this is my most recent design iteration that had accommodation for the wood block as well as the cutout for the stepper, but I'm not 100% certain now that I'm looking at it. But this is my most recent file date for this design. Okay, the next thing to look at is the parts for the X-axis, both the one that I had to modify, which is this one, and the one that I made from scratch, which is this one. And you're going to want to go download the smooth X-axis for Prusa i3. I'll link that down in the description of this video, but that's a whole STL pack that includes all the parts that you're going to need, and probably some you don't need. But the ones that you're not going to use in that download are the mount for the end stop on the X-axis. This part replaces that, and it is a significantly different part from the part that comes in the STL pack, because again, this is that piece that not only holds the actual mechanical end stop switch, but also has provisions for mounting the wire and running it through here to hide it. And that does really work nice to clean up that side of the printer versus just having the wiring for the end stop exposed. It carries it all the way over to where it basically combines with the wiring bundle for the stepper motor on the left side of the printer. And this one I modified. This one I didn't design from scratch. This is just, I believe I either had to lengthen it or shorten it. I can't remember which. But this is the side over here that gets yanked on from that thumb screw and machine screw. And it's pulling on the tension for the Y belt. The bearing for the Y belt, the little pulley rides inside of here. And I think I had to modify the width of this to work with the bearings and pulleys that came in the ANET A8 kit, so I didn't have to buy new ones. So I think that is it for all the parts that we talked about in the printer. Let's go back and see what else I missed. All right, I realized there's one thing I forgot to mention when talking about the aluminum face of the frame here. I added a piece of adhesive neoprene foam on the front here for this guy to ride against as this carriage goes back and forth. You see how it moves across there as this guy moves? That's just so that the edge of the aluminum, even though it's not that sharp, I've knocked it down, doesn't eventually eat into our cable guide here. And I zip tied this guy up here in place. And that's held up really well. I kind of thought for sure that this was going to end up wearing away just from this, but looks really good. I mean, it's been running on there for probably thousands of hours at this point, and it's still doing great. Now, if you're wondering why your ANET A8 doesn't have a sticker on the top of the gantry like mine does that looks like this one with your serial number, that's because I made this one. The original sticker had just the serial number and it wouldn't even stay stuck to the frame. It kept coming off. So I designed this one in Photoshop and then printed it out on a dye sublimation sticker printer. I'll include the PSD for this if I can dig it up in the STL pack for all of the mods on this machine. So in case you want to make your own, you can do that. Obviously change out the serial number to be yours. That is the actual serial number for my printer. Okay, the last thing I want to talk about on this machine is also something that I'm not happy about in its current iteration, and that's the spool holder. I actually designed the spool holder to key right onto the machine. It's a little tough to see from this side because it's actually covering the frame, but if we take a look at this side is basically just a mirror image of the top of the frame on that side. And you can see this tab here. That is this vertical piece keying into that piece. So that piece, see, it kind of forms almost like a T up here at the top, and this screw goes down into this piece. I think there's a nut embedded in there's a nut embedded in the plastic there. The other side, again, it's a mirror image, and I designed the spool holder to just key over the whole back of the printer. This whole thing slides on and off. I don't know if I can do it with one hand. There, I slid it back a little bit. You can see it just keys into the frame, and there's even a slot up here for where the screw is. That part works great. The problem is I went way out of my way to incorporate a threaded rod up here, a set of bearings, and I stole these wedge pieces that go into the spool. I stole them from somebody else's spool holder design, as well as this long threaded piece. And the problem is it spins too freely. And I wanted it to spin freely. The problem I was actually trying to solve was, I can't even remember what spool holder I was using before this, but the filament didn't turn on the spool holder smooth enough. It was actually sometimes yanking up on the extruder during prints, and any movement down here on the extruder is going to change where our layer line is down on the print. So I came up with the idea of, all right, well, we'll mount it on bearings, right? Well, now it's too smooth. So what happens is when you're printing and the filament gets any twist in it, this thing just starts going. And I've seen it unwind like half the spool somewhere between here and the printer, and it gets like all tangled up around the machine. I still have that problem to this day. I've somewhat mitigated it by tightening up the nut just to keep a little pressure on the bearings. That doesn't really work. It just loosens up again, and the problem persists. I actually want to fix this. Let me fire up CAD and see if I can design one of these that instead the spool just rides on, and see if we can hit that sweet spot with the amount of resistance that we want for the filament unwinding without having too much. All right, and here's the design update that I came up with for this one. I didn't have to modify anything down here at the bottom at all, which is good, because I remember going through a lot of iterations of this until I had just a perfect sliding fit on that frame. So you see this is curved in here. This accommodates the back part of the frame that you're sliding into. It has the cutout for the vertical piece, and also has this slot up here to provide clearance for that screw along the top. And if I recall, I intentionally brought this face down a little bit to ride against that screw just so it stays locked in place. The part that I've changed is up here at the top. Rather than having that mount for the threaded rod, I've basically just extended this over like, more or less any other filament holder that locks onto the top of a, modern printer. And I'm hoping that this is going to be smooth enough that we get sort of the right balance of easy rolling or sliding of the filament spool on here, but not so easy that it's able to unwind like the old one. And I went to great lengths to make sure that this thing can be printed without supports and that has good bed adhesion. This entire, here, let me explode this. This entire face here that you see selected, that is all flat. That whole thing sits against the bed on the printer. So you should have no problems with adhesion on this. Maybe do a brim if whatever you're printing this on. Sometimes you don't always get the best stick on the bed, and it'd be pretty easy to trim that brim off, but you don't need any supports for this. The whole thing will print standing up just like this. All right, let's see how it works. All right, I've actually been messing with this for a few minutes. At first it was nice and smooth, and then after a couple minutes of just continuously turning it, I actually unwound the filament and rewound it a few times, just kind of yanking on it. It started to get too tight. What was happening was the PLA was probably wearing here on the top, and there was like a little bit of powder on the top, and it started to just hang up. I don't know if it was hanging up enough that it was going to lift up on the extruder. In printing, I didn't get that far to test it, but it lost that sort of nice balance between smooth with some resistance when I first put it on. And the way that I resolved it was I actually just took a little bit of this stuff, and you guys probably already have some of this sitting in your 3D printer stuff stash, because this is the best stuff to get to use on your Z-axis rods. Anything where there is like a threaded rod like that, you don't want to use this as the lubrication on your smooth rods. The Super Lube company actually makes another product. Actually, let me go grab it. Okay, this is not unique to just this printer. These are the two products that you want to make sure you have on hand for really any 3D printer that you own. This stuff is like an oil. It's a synthetic oil with Syncolon PTFE in it. This is the stuff that I use on all of the smooth rods. Either the ones for the Z or for X and Y. Don't use this on your carbon fiber rods on a bamboo printer, but any metal smooth rods, you want to use this stuff. And I'll link both of these down in the description of the video. This is a grease. It's similar formulation, it's just thicker. This is the stuff that you want to use on any of your threaded rods where there is thrust being applied to them. So again, I'll link both of these down in the description. But the reason I'm bringing this up is I took just a little bit of this Super Lube grease and I just smeared it all along the top of this, kind of worked it in with my finger and then wiped it off with a paper towel, and now it's perfect. Yeah, that is like dead perfect with this spool on here. All right, guys, I think that is pretty much all of the mods that I have done to this machine. And like all of the projects that we cover on this channel, all of the STLs will be available for free on my site, fpfdesigns.com, and that is linked in the description of this video as well. All right, I'll give you guys a little sneak peek. The next video that's going to be coming out on this channel is going to be my review video and fix video for the Neptune 4 Max printer. I've held off doing the review on this because I've had nothing but trouble with getting consistent height across the entire surface on this bed. And a lot of people have worked on this issue and have come up with various fixes, but it seems to me that everyone has actually missed what's really going on with the bed on this printer. And I'll give you another little hint over here. Maybe you guys wonder what I'm doing with this guy, but I'm going to try and finish up the video on this guy on either to publish tomorrow night or sometime on Sunday. So it's not, you're not going to have to wait till next Friday. It's not going to be really a functional print video. It's going to be a review slash fix video on this Neptune 4 Max, and I'm really excited to share it with you guys because with the work I've done on this, I am now getting consistent extrusion across the entire print bed, all the way to the corners, which was completely unachievable on this printer before, and I'm really excited to talk about it. All right, guys, as always, thanks for hanging out with me for this week's video and the designs on this machine. And a couple of you in previous videos have actually asked to see more machining content as well. So hopefully you enjoyed the lathe work and machining content in this week's video. I am definitely not a machinist, so feel free to tell me down in the comments all the things I did wrong in making this, but I really do enjoy working with the mill and the lathe as well. So this is by chance your first time on the channel. We do a new functional print every single Friday. Sometimes it's something like this where we're covering a bunch of things at once. Other times it's just a single print that fixes something else I have out in the shop or just around the house, or sometimes even out in the yard. Or more often than not is adding functionality to something that's already out there. So if you're into that sort of thing, if you like the design and engineering aspect and functional printing, check out my other videos, hit that like button. And if you see a bunch of stuff you like in my other videos and you want to hang out with us every Friday, hit that subscribe button. And guys, if you do, I'll see you next Friday.